Hello, this is Mr. Muller for section 11-8, multiplying and dividing radical expressions. So there's going to be three different kinds of problems that we're going to learn about today. So the book here will explain pretty much every single step. Some of you might be able to come up with shortcuts, so you might be looking at the steps saying that's a lot of work, but it's really not. The book just literally explains every single thing you need to do. So if I have a problem like this, like square root of 8 times square root of 6, I'm going to multiply them together, end up square root of 48, and then I can split up square root of 48 into 16 times 3, and we know the square root of 16 is 4. So my final answer here is going to be 4 root 3. Same thing here, if I have 2 square root of 5 squared, which means 2 square root of 5 times 2 square root of 5, well, 2 squared is 4, square root of 5 times square root of 5 is square root of 25, which is really just 5 then. And so I end up with 4 times 5, which is 20. So remember, if I have square root squared, those are just going to cancel out, and you're pretty much just going to be left with whatever that number was underneath that we started with. Same things happens with when we multiply variables. 3y, or root 3y times root 12y is going to end up being 36 root y squared. Book doesn't do a good job of writing this one out. I would do it what I just said, where I would end up with 36 root y squared. Square root of 36 is 6. Y squared, remember, they can come out in pairs. So I'm going to end up with y. So 6y would be my final answer there. Here's one that the book explains, and I agree with. So 5 square root of 5 times square root of 10 is square root of 50. And we break down 50 into 25 and 2. And then the square root of 25 is 5. So I'm left with 5 root 2. Some problems are going to look like this, where I need to distribute first. So if I have square root of 3 times 7 minus root 8, I have to multiply all those out. So this is going to become 7 root 3 minus square root of 24, because it's square root of 3 and 8. And that's going to split up into 6 and 4. And we know the square root of 4 is 2. So this is going back to last section. We can't combine these. So 7 root 3 minus 2 root 6. So we've got to do some multiplication before we can solve those problems. Same thing here. So I'm really going to end up with 2 root 16 plus 2 times 18 is 36, which are going to give us some nice whole numbers there, because we know the square root of 16 is 4, and we know the square root of 36 is 6. So it really just ends up being 4 plus 6. Second kind of problem that you're going to have are foiling problems. So remember, FOIL, first, outer, inner, last. So pretty much the same thing, except now we're going to have those square roots there. So 4 times 5, there's my 20. 4 times root 3, there it is in blue, 4 root 3. 5 times root 3, there it is in purple, so 5 root 3. And then root 3, which is really root 9, which we know the square root of 9 is 3. So then I kind of have those terms I can combine. So there's my 4 root 3 and my 5 root 3, which gives me my 9 root 3. There's my 20 and my 3, which gives me a 23. And I can't combine those anymore, so I'm left with 23 plus 9 root 3. Kind of the same thing here. So I have 3 times 2, which is going to be 6. You see that there in red. 2 times root 8, which is 2 root 8. 3 times root 8, which is 3 root 8. And then square root of 8 and square root of 8, which is going to be 64. But we know square root of 64 is 8. Notice how that one's negative. So it's going to be a negative 8. So then I end up with 6 minus 8, which is that negative 2 there. And then negative 2 root 8 plus 3 root 8 is just going to give me a 1 root 8. Now I can break down root 8 into 4 and 2. And then we know the square root of 4 is 2. So I'm left with negative 2 plus 2 root 2. And then the last kind of problem we have are division problems. Okay, and to solve division problems, we need to get rid of the square root on the bottom. And to get rid of the square root on the bottom, we need to make it a perfect square. So like for this problem, to make square root of 3 a perfect square, we're going to multiply by the square root of 3, because that gives us square root of 9. So square root of 3 times square root of 3 is square root of 9, and we know the square root of 9 is 3. So I end up with square root of 33 on top because of the 11 times 3, and I'm left with 3 on the bottom. For a problem like this, so I have square root of 20 on the bottom. I could multiply by square root of 20, but that's going to give us a really big number. And there's a simpler way to get to a perfect square that we know, and that's by multiplying by the square root of 5, because 20 times 5 is 100. Okay, so then I multiply both sides by 5, so I'm left with 65m on top. 20 times 5 is 100, and I know square root of 100 is 10. Something like this, square root of 5. Best way to do it is get to 5 again. So 25, square root of 25 is 5. Here, to get to 12, we would multiply by square root of 3, because that would give us 36, and we know the square root of 6 is 6. So just not multiplying by whatever the denominator is, we're multiplying by whatever would give the denominator a perfect square.